So we're starting our new topic. This is the first of the year 13 topics, and it's called the water cycle and water insecurity. So to help you with this, what I thought I'd do is I'd upload the lessons as YouTube videos, go through the PowerPoint, talk over the top, explain things that you need to do. If there's any tasks I want you to do, just pause the video, complete the task, and then when you're ready, press play again, and we'll go through and you can mark your own work from the answers that I give you. So this topic, the water cycle, we start by looking at processes, what's going on, things like the water cycle. Then we're going to look at how that can be influenced, short time scales, so days, all the way up to longer time scales, so we can talk weeks, decades, that kind of thing. We'll then look at how water insecurity can occur and why it's becoming a global issue. How this is assessed, it's actually split with the energy topic. So I can't say for all certainty you'll get a 12-mark essay or you'll get a 20-mark essay. You'll either get a 6, 8 and a 12, or you'll get a 12 and a 20. Whatever you don't get for water, you'll get in the energy section, because they're combined in what we call section C. What I do know is the command words will be explained for the 6 and the 8 markers, and they'll be purely knowledge. It'll be an assess for a 12 marker, so 3 marks for knowledge understanding, 9 marks for application, and there will be a 20 mark evaluate, which has 5 marks for knowledge understanding and 15 marks for your application. So we do have a range of case studies that we need to cover as we go through this topic. Look at the Amazon, the Yukon, the Indus. We'll look at some drought in Brazil, flooding in the UK. We'll look at the Nile as an example of a river, and then we'll look at China transfer, which we've covered before at GCSE, and finally we'll look at Singapore and what they're doing to be more sustainable. So this lesson is all about introducing the global hydrological cycle, the water cycle pretty much, and our aim is to evaluate the relative importance, so how important are different stores and different fluxes. So fluxes are just flows within the water cycle. So we'll start with inquiry question 1, processes. Looking at the global hydrological cycle is of enormous importance to life on Earth, and we'll look at it in terms of what we mean by a closed system that's driven by solar energy, so energy from the sun, and gravitational potential energy. That means that things get pulled down due to gravity. It rains, the rain falls. The rain falls on the land, it then flows downhill, or it soaks into the soil. That's all driven by gravity. That's what gravitational potential energy means. So we're going to start by doing a SWOT analysis. And what a SWOT analysis is, it's where you go through the strengths. So by that I mean the benefits, the positives that water creates. It sustains life, you grow food, you can operate machinery, you can drive industry. Then look at the weaknesses. So by that I mean the problems. So the problems water can create, flooding, for example, or drought if there's a lack of. Then opportunities, so I want to think what good may come in the future due to water. Think of, I don't know, technology, inventions, future developments. And finally, the threats. So what problems may occur in the future? Are we going to have a lack of water? Are we going to have too much water? And so to answer that, I want you to set it out, split a page into 4, just like I've got on the slide. Watch these 2 videos. I'll put the link in show my homework, so if you click on it, it'll take you to the different videos. Watch those, fill in your SWOT analysis, and then we shall move on. So you can have a go at applying what you may previously know to these 2 pictures. So quite different landscapes, different biomes. You need to start by thinking, well, what is different between the 2? And why is it different? So write down your thoughts. See if you can explain how you think that might link to our lesson, what we're going through today. Then once you've done that, press play and I'll give you the answers. So what is different? As you can see, the one on the left has a much colder climate. You've got snow in the background. The one on the right is much hotter, it's your rainforest. The one on the left seems to be a drier landscape. There's a lack of vegetation, so lack of precipitation. The one on the right, lots of precipitation, lots of rain falling. Why is it different? Well, they're different because they're located in different parts of the world. They're different biomes. They have a different climate. they have different amounts of energy, they have different amounts of rainfall, and as a result, you get a completely different landscape. How does that link to our lesson then? Well, it links to our lesson because we're doing all about the hydrological cycle, the water cycle. So the inputs, the flows are different in that picture on the left and that picture on the right, and that's what we'll go through now. So you've got the letters A to Q. I want you to write down what you think the processes are. So some of them might be fluxes, might be flows, some of them might be stores. So for example, G, that's the ocean, isn't it? It's a store of water in the ocean. H, the movement from that water in the ocean into the atmosphere, evaporation. So go through all of those, write down what you think they are. Once you've done that, press play and you can get the answers. There you go. So go through, have a read through those key terms, write down what you got from each of them. If you got them incorrect, you can change them. If you can print off the diagram, print it off. So you can see it's the water cycle, isn't it? It starts in the oceans, evaporation, air moves from a liquid in the oceans into a gas in the atmosphere. That can then cool down through condensation, turn back into a liquid, water droplets that we can see as clouds. That's all part of the atmospheric store. That water in the atmosphere can then get back onto land through precipitation. It can land as the frozen form, so solid, ice, or it can form as liquid form, rain. You've also got some processes called sublimation and desublimation, which I'll come back to in a second. But then all of that water, what that does is it flows back in different ways, but ultimately it ends up back in the ocean. And those processes, they take different amounts of time to move. Oops, turn the phone off. Oh, it's Mrs. Mosley, how funny. Yeah, so they take different amounts of time, and we'll come back to that next lesson on that. So from that diagram, I want to identify two fluxes, so two flows, two ways that water moves, and two stores, so where the water is actually held, it's stored. Which of those fluxes and which of those stores do you think are the largest, so contain the most water? And do you think this might change? This is the challenge. So would those processes, those flows, those stores, would they be different in different locations or at different times of year? If there are any words on that diagram that you don't understand, I suggest you make a glossary, so write down the keyword and write down the definition of it. So your fluxes, your flows then, they're things like evaporation, evapotranspiration, surface runoff, sublimation, desublimation, precipitation, snowmelt runoff, stream flow, infiltration, groundwater flow, your spring, stream flow, fog drip, surface runoff, plant uptake, some more evaporation. They're your flows. Your stores are things like your ocean, your atmosphere, ice and snow, fresh water, groundwater. I think that's pretty much all of them. So your largest store of water is going to be your ocean. Your biggest flows, they're going to be things like your evaporation and your precipitation, but they also occur in different amounts in different places. If it's hotter, you get more evaporation, which means you can then get more precipitation, but we'll come back to that later. Out of the keywords, I'm assuming the only one you don't know is sublimation and desublimation. All that means, so sublimation is when something goes straight from a solid to a gas, so it doesn't become a liquid, and that can happen sometimes with ice. Desublimation is when it goes straight from a gas to a solid, so straight from water vapour into, I don't know, snow or ice crystals, something like that. Okay, now you can have a go at reading through this information. You might want to pause it whilst you read this. Then on the next slide, there's a range of questions. So I'll upload this PowerPoint, show my homework as well. So if you want to, you can download it and print it or whatever you may be. So read this, use it to answer the questions. Then you can self-mark the questions because I've got the answers. And I'll go through some of the key terms on there for you. So number one, the longest residence time. So where is water stored for the longest? Well, it's groundwater. You can have ancient groundwater that's been there thousands and thousands of years. Solar energy concentrated in the tropics, so near the equator, where the energy from the sun is greatest. Type of rainfall, it's called convection. So that's when hot air rises, turns into clouds, big storm clouds, it rains. Convection, caused by warm air rising. Percentage of water is fresh water. It's 2.5%. That's it, all water on Earth. Only 2.5% is actually fresh water. What's the cryosphere? That's just ice, your glaciers, your ice caps. What percentage of precipitation does vegetation in the rainforest consume? 75%. That leaves 25% to flow into the rivers. What flux does deforestation reduce? It reduces evaporation because water is lost out of the system, back into rivers, back to the ocean eventually. What type of rainfall occurs in the tundra? Frontal or orographic? Frontal, that's two different air masses. When they meet. Orographic, that's when water is forced up over land. That causes your clouds, causes your rain. Annual precipitation in the rainforest, 200 millimetres a year. We get about 400 or 500 in Nottingham, so 4 times what we get. What percentage of precipitation in the rainforest reaches rivers? Less than 25%. Right, so let's go back to this then, and I want you to have a go at putting into writing what is different, why is it different, based on what we've gone through, what we've covered in today's lesson. So write that down in a paragraph for me, please. Right, and that is it. Hopefully that was a bit better, that was helpful for you. I'll continue to do these in the future. Any questions, leave me a comment on showing my homework. Otherwise, take care. See you soon. Bye-bye.